Our creator is the best planner for us. Assalamu alaikum everyone. This is Jahanur Rahman. I am so happy to give me the opportunity to present my presentation. My today's topic is Joule-Thomson effect and its application. Nothing can be discovered without a discoverer. James Prescott Joule and William Thomson Baron Kelvin discovered the Joule-Thomson effect. My topic is introduction of scientist, history of Joule-Thomson effect, description, the application of Joule-Thomson effect, and summary. First of all, introduction of scientist. James Prescott Joule. He is the British scientist. He was born in 24 December 1880 and died 11th October 1889. He is known for many scientific work. Joule-Thomson effect is one of them. Secondly, William Thomson Baron Kelvin. He is also British scientist. He was born 26 June 1824 and died in 27 December 1907. He also carried on equal share of Joule-Thomson effect. History of Joule-Thomson effect. In 1852, William Thomson Baron Kelvin and James Prescott Joule discovered the Joule-Thomson effect. Description. What is Joule-Thomson effect? Joule-Thomson effect is the change of temperature of a real gas or liquid. It is forced through a valve or porous plug while keeping it isolated so that no heat change with the environment. Now we can see how can it work. When the gas under the high pressure, it is intermolecular forces. Then, when it passes through a porous plug in low pressure, the molecules are separated from each other. In this time, the gas absorbs the energy, so decrease the temperature. For repeating this process, the gas will convert it to liquid. The adiabatic expansion of a gas be carried out in a number of ways. The change in temperature depends not only the initial or final pressure but also on the manner in which the expansion is carried out. If the expansion process is reversible, meaning that the gas is in thermodynamic equilibrium at all times, it is called an isentropic expansion. In a free expansion, on the other hand, the gas does no work, no heat absorbed, so the internal energy is conserved. The method of expansion of the method of expansion discussed in this article, in which a gas or liquid at pressure P1 to flow the low pressure P2. In this time, without significant change in kinetic energy, this is known as Joule-Thomson expansion. This expansion is inherently irreversible. So the expansion, during this expansion, enthalpy remains unchanged. This is many application of Joule-Thomson effect in this machine. Now we can see the second graph. The red line indicates Within the region boundary, the red line indicates the Joule-Thomson expansion produce cooling. In this time, the coefficient of Joule-Thomson effect is positive number. Outside the region, the expansion produce heating. And in this time, the value of the Joule-Thomson effect coefficient is negative. And the gas liquid coexistence line shown by blue line termination at the critical point. The dash point indicates the supercritical position of nitrogen. In this time, the nitrogen in this time nitrogen stays some properties of gas and some properties of liquids. And this is the derivative form of Joule-Thomson effect. Here, mu Zt is the Joule-Thomson effect coefficient, delta T is the change of temperature, delta P is the change of pressure with respect to enthalpy. V is the volume of the gas. Cp is the heat capacity of constant pressure. Alpha is the coefficient of thermal expansion, T is the temperature. So, mu Zt is the V by Cp into alpha T minus 1. Now we can see the first graph. This graph shows the relation between temperature and Joule-Thomson coefficient. If we increase the temperature, the Joule-Thomson coefficient will decreases in carbon dioxide, argon and nitrogen. But hydrogen and helium partially changes, or if we change the temperature, the Joule-Thomson coefficient is increasing. So hydrogen and helium don't turn to be liquid. Now the application of Joule-Thomson effect. The Joule-Thomson effect is used in the refrigeration, air condition, and the effect is applied in the Linden technique as a standard process in the petrochemical industries. This cooling effect is used liquefy gases and also in cryogenic application. As for example, for the production of liquid oxygen, liquid nitrogen and liquid argon. Liquid oxygen is shapes live, liquid nitrogen is used in the fertilization companies, and argon used as galvanizing industries. Summary: although by using refrigeration air conditioner produce CFC, it destroys the ozone layers, but the use of Joule-Thomson effect is very important in our everyday life.